Are you paying every month for AI access tied to those big cloud services? And maybe worrying, where your private thoughts or your company-sensitive docs are actually going. We kind of assume powerful AI needs like a $20,000 supercomputer. But that whole idea, it's pretty much outdated now. Welcome to the Deep Dive. Our mission today is to take this stack of research we've got here, focusing on tools like Ollama and LM Studio, and turn it into something really clear, actionable. We want to make local private AI something you can do right now on a laptop you probably already have. We'll cover the why, the privacy wins, the cost savings, and then the how, breaking down things like quantization and picking the right AI model for your machine.
Right. This is really all about taking back control,
Yeah.
over your own compute. These terms like parameters and quantization, they sound complicated, maybe a bit intimidating, but we're going to pull back the curtain on those. We're going to show you exactly how you can get powerful private AI running today using the gear you've already got sitting right there.
Okay, so let's unpack that first part. The motivation. Why bother downloading software, maybe messing with the terminal, when you can just open a chat window in your browser? It seems easier. The sources we looked at lay out 6 pretty compelling reasons.
Yeah, and the first one hits you right away, cost.
Yeah.
Once you download that initial model file, that's it. It costs nothing more to run forever. No monthly fees, no paying per query, none of that. The only real cost is like a tiny bit of electricity.
And tied right into that is getting away from limits, right? Every commercial service puts caps on you, especially if you use it a lot.
Exactly. With these local models, you could run 1,000 queries in an hour if you wanted. The AI itself never tells you, nope, you've hit your limit for today.
But privacy, you mentioned control. That seems like the really big one for a lot of people.
Oh, it's huge. Probably the biggest driver. See, when you chat online, your conversation, your prompts, your data, it all goes to someone else's server. Who knows where?
Yeah.
Running it locally. Everything stays right there on your machine, 100%. Your secret company plans, your personal journal ideas, whatever it is, it doesn't leave. That peace of mind, you can't really put a price on it.
And then there's just the practical side. You get actual offline capability. I mean, you could be on a plane, no Wi-Fi, or maybe somewhere remote.
Yeah.
The AI just works anywhere.
Yeah, that's super useful. And you also get version control. This is kind of neat. If you find a model version that just works for you, gets your style, you can keep that exact version indefinitely. You're not forced into updates that might suddenly change how the AI responds, which definitely happens with the big online ones.
Right. And the last one is customization. This sounds more advanced, but really powerful.
It is. You can actually fine-tune these models.
Yeah.
That means you could say, teach it all the specific jargon for your industry, or even train it to mimic your personal writing style. That kind of deep, personalized training, just impossible with the closed-off commercial models.
Okay, so that covers the why. But there's always that nagging question. Are these local models actually any good? I remember trying some early ones, and they were, well, not great.
Yeah, they used to be pretty basic. Kind of dumb, honestly.
Is that still the case? Or is that just a myth now?
That myth is completely busted. Seriously. The open source world is moving incredibly fast. We're seeing models released almost daily that often match or even beat older systems like, say, GPT 3.5. And the crucial part is, they run fine on regular laptops, MacBooks, Windows machines. You don't need some monster gaming rig anymore.
Okay, so if they're powerful now, and free, and limitless, what's the catch? What's the main trade-off compared to just using a cloud service?
The trade-off really comes down to managing your own computer's memory. That's the main constraint.
Right, memory. That brings us perfectly into the next bit. We need to understand what an AI model is, file-wise, to get why memory matters so much.
Okay, yeah. So an AI model, at its core, it's just a file, a really, really big file. Think of it like stacking billions of tiny Lego blocks made of data. This file contains billions, literally billions of numbers. We call them parameters or sometimes weights. These numbers represent everything the AI learned during its training, all the patterns, the connections. So when you download an 8 billion parameter model, you're grabbing a file with 8 billion of these numbers. It's chunky.
Billions of numbers. Okay, and you need something special to actually read and, well, run that giant file. That's where Ollama comes in.
Exactly. If the model file is like that super dense, complex sheet music, Ollama is the specialized music player designed just for AI scores. It does 3 main jobs really well. First, it's a downloader. It knows how to handle fetching these enormous multi-gigabyte files reliably. Second, it's the engine. It takes those billions of parameters and loads them into your computer's active memory so the AI can actually think. And third, and this is kind of cool, for flexibility, it acts as an interface. It quietly starts up a sort of hidden software door on your computer. Technically, it's an API server running on localhost. This door lets other applications on your machine talk directly to the AI model that Ollama is running.
Okay, that interface part sounds important for later, but you mentioned memory. And there's a key difference depending on the type of computer someone has, right? Mac versus Windows.
Yes, absolutely critical distinction here. It changes how much memory is actually available for the AI. So if you're on a Mac with an Apple Silicon chip, M1, M2, M3, whatever, you have what's called unified memory. This is great for AI. It means the main processor, CPU, and the graphics processor, GPU, share the same pool of RAM. So if your MacBook has, say, 16 gigabytes of RAM total, pretty much all 16 gigs can potentially be used by the AI model. It's simpler.
Okay.
If you're on a typical Windows PC, especially one with a dedicated NVIDIA graphics card, things are different. You usually have your main system RAM, maybe 16 or 32 gigs. And then crucially, the graphics card has its own separate memory called VRAM or video RAM. For AI tasks, that VRAM on the graphics card is the golden ticket. It's much faster for the parallel processing AI needs. So ideally, the entire AI model needs to fit into that graphics card's VRAM. That's often the limiting factor on PCs.
That makes sense. The version control aspect you mentioned earlier really resonates too. I have to admit, I still wrestle sometimes with prompt drift, when you're talking to an AI, and halfway through, it just seems to forget what you asked it to do initially. It's frustrating. So I'm genuinely grateful these local models let you just stop and restart with a clean, predictable version whenever you need that consistency back.
So, okay, let's make it concrete. Someone wants to try this. What's the simplest way to get started?
Easiest path. First, download Ollama from their website. Install it like any other app. Then you open up your terminal. Yeah, that black command line window. Don't be scared. And you just type one single command. Ollama run Llama 3.8b. Hit enter.
Ollama run Llama 3.8b. And what does that do?
That tells Ollama, go find the model named Llama 3 with 8 billion parameters, download it if you don't have it, and then run it. It'll start downloading. That specific model, Llama 3.8b, is a fantastic starting point. Very capable, but the file size is manageable, only about 4.7 gigabytes. Most modern machines can handle that download and have enough memory to run it. Okay, 4.7 gigs is manageable, but these model files are still pretty big. If you start downloading a few, you could eat up, I don't know, tens, maybe hundreds of gigs pretty fast. How do you, keep track of what you've installed and clean things up?
Good question. Ollama has simple commands for that, too. You can type Ollama list to see all the models you've downloaded and their sizes. And if you want to remove one to free up space, just use Ollama ARM followed by the model name, like Ollama ARM Llama 3.8b. Easy to manage.
Okay, easy enough. Ollama list and Ollama ARM, got it. But hang on, you said the 8 billion parameter model is 4.7 gigabytes. If a parameter is a number and there are 8 billion of them, shouldn't the file be much, much bigger? How does it work?
That brings us to the real magic trick of running modern AI locally. It's a technique called quantization. This is the absolute key that lets these huge, powerful models shrink down enough to fit onto regular computers.
Quantization. Okay, what is it doing?
Basically, it takes all those billions of very precise numbers inside the model, like 13.4159265, and it makes them less precise. It might round them down to something simpler, just 13.4. Think of it like image compression. You know how you can take a massive, super detailed raw photo file, maybe 100 megabytes, and save it as a JPEG that's only like 5 megabytes? Quantization is doing something similar, but for the AI's knowledge. It's a kind of lossy compression, but highly optimized for these neural networks.
Lossy compression, doesn't that mean you're losing information? Is the AI getting dumber when you quantize it?
That's the amazing part. You do lose a tiny bit of precision, yes. But the trade-off is incredible. Quantized models can shrink by 50, 60, even 70% in file size, but they typically only lose maybe 10 to 20% of their raw performance score on benchmarks, sometimes even less.
Wow.
It's a fantastic deal. You get a model that's drastically smaller and needs way less memory, but it's still incredibly smart. That's why that 8 billion parameter Llama 3 model ends up being only 4.7 gigs instead of 16 or 30 gigs.
Whoa. Okay, hold on. If you can shrink models that much with only a small performance hit, you could potentially take something massive, like a 70 billion parameter model, quantize it, and maybe actually run it on a high-end laptop.
Exactly. That's happening right now. People are running quantized 70B models on Macs with enough unified memory or PCs with beefy graphics cards. It completely changes the game, democratizing access to really powerful AI. It's not just for giant data centers anymore.
Is that 10–20% performance loss ever really noticeable, though? If you're asking it to do something really complex or creative?
Honestly, for most everyday tasks, writing emails, summarizing articles, brainstorming ideas, even coding, Help you likely won't notice the difference between a quantized model and the full precision original. Maybe if you were doing highly specialized scientific modeling or something requiring extreme numerical accuracy, you might stick with a full-size one. But for 95% of us, the efficiency gained from quantization is absolutely worth that tiny dip in performance.
Okay, that makes sense. So assuming we're using these standard quantized models that Ollama usually downloads by default, can we give people some simple guidelines for picking a model based on their computer's memory?
Yeah, definitely. Its simple rules of thumb work pretty well here. If your machine has about 8 gigabytes of available RAM or VRAM, if you're on that NVIDIA PC, you should probably stick to the smaller models like 7 billion or 8 billion parameters. So that Llama 3.8B we keep mentioning is perfect.
Got it. 8 gigs, stick to 7 or 8B. What about more memory?
If you've got 16 gigabytes of RAM or VRAM, you can comfortably run larger models like 13 billion or even up to around 16 billion parameters. For coders, a great one in that range is DeepSeek Coder-V2.16B. It's specifically trained for programming tasks and it's really impressive.
Nice. DeepSeek Coder-V2.16B for 16 gigs. And for the power users, people with 32 gigs or more.
Ah, now you're talking. With 32 gigs or more, you can start running the real heavy hitters. You can handle 34 billion parameter models, or even the big 70 billion ones like Llama 3.70B. And another interesting one to try, maybe in the smaller size like 7B, is Wizard LM 2.7B. It's known for being less censored or aligned than some others. It gives more direct, sometimes unfiltered answers, which can be useful depending on what you're doing.
Okay, lots of options. But running commands in the terminal is cool for setup, maybe for scripting, but for just chatting with the AI day to day, most people probably want something friendlier, a nice interface. How do we get that?
Right. You want a proper chat window, history settings, all that. That's where tools like LM Studio come in. Or other similar apps, there are a few now. LM Studio basically provides that polished graphical user interface, a GUI, that sits on top of your local models. It's a dedicated chat program. It's really good because it often shows you helpful info, like how much CPU or RAM your AI is using while it's thinking, and it makes it super easy to just switch between the different models you've downloaded with a click.
Okay, LM Studio sounds like the answer. But if we already downloaded our models using Ollama, and Ollama is running the engine, we don't want LM Studio to download everything all over again, right? That wastes space.
Exactly. You want to avoid doubling up. The smartest way is to install LM Studio, but then configure it to talk to the Ollama server that's already running on your machine. Remember that hidden door Ollama opens, LM Studio can just connect directly to that. Most of these GUI tools have a setting somewhere to point at an existing Ollama instance. You tell LM Studio, hey, don't download models yourself, just talk to Ollama at localhost.11434. Then boom, all the models you got with Ollama just appear in LM Studio's chat interface, ready to use. No redundant downloads.
Perfect. So connect LM Studio to the running Ollama. That's the efficient path. Now, once you're set up with a nice interface, the quality of what you get out still depends heavily on what you put in, right? Good prompting is still key.
Oh, absolutely. Garbage in, garbage out still applies, even with powerful local models. The sources we looked at really hammered this point. You need detailed prompts. They suggest focusing on defining 5 key things for the AI. Its role, the specific task you want done, the overall goal, the reason why, and the desired tone.
Role, task, goal, reason, tone.
Okay.
Yeah.
If you just say, write an email, you'll get something generic. But if you structure it like, okay, act as a professional employee, that's the role. Your task is to write an email draft to my manager, whose name is Sarah. The goal is to politely request a 2-day extension on the quarterly report. The reason is that the final sales data only arrived this morning. Please maintain a polite but confident tone.
Much more specific.
Way more specific. And you'll get a much, much better, more tailored result almost every time. That level of detail really guides the AI effectively.
Okay, good prompting advice. Now, what about troubleshooting? People trying this for the first time might run into things that seem weird. Let's normalize a couple of common experiences. First one, your computer might suddenly sound like a jet engine and feel pretty warm.
Yeah, expect that. Running these AI models, especially the bigger ones, is computationally intensive. It uses a lot of processing power, often on the GPU. So your computer's fans are going to spin up fast. You'll hear them. The machine might get noticeably warm. That's just the sign it's doing the heavy lifting required. It's totally normal. Don't panic.
Okay, loud fans and heat are normal. Good to know. Second thing, the very first time you ask a newly loaded model a question, it might seem really slow to answer, like maybe 20 or 30 seconds of silence.
That also happens, and it's expected. That first query involves Ollama loading all those billions of parameters from your storage drive into the active RAM or VRAM. That takes time. Think of it as the AI waking up or warming up. Once it's loaded into memory, though, any subsequent questions you ask in that same session should get much, much faster responses, usually just a few seconds.
Right, so be patient with that first prompt.
Exactly. And just a reminder about storage, keep an eye on those file sizes with Ollama list. Clean out models you're not actively using with Ollama wrong. And really, the final piece of advice is just experiment. Try different models. See how Llama 3 feels for general writing. Then switch to DeepSeek for some coding. Maybe try Wizard LM2 if you want less filtered responses. Find the personality and skills that best fit what you need to do.
That seems like a great place to land.
Yeah. If we just zoom out for a second, think about what we've covered. The core achievement here is pretty profound, actually. You, the listener, now have the practical knowledge to harness really powerful AI tools completely for free, privately, on your own machine, offline if you need to be, with total control over which version you use and absolutely no usage limits imposed by anyone else. You've essentially bypassed the dependence on those big centralized cloud providers for this capability.
It really is a feeling of taking back control, self-sovereignty over your computing, in a way. The future of AI isn't just happening out there in the cloud, it's shifting rapidly onto the hardware you own. So don't just listen to us talk about it. Take the advice from the source material. Go download Ollama. Open that terminal, type Ollama run Llama 3.8b, and start exploring today.
And maybe a final thought to chew on. We talked about quantization, right? How losing a tiny bit of numerical precision gives us these massive gains in efficiency, letting big models run locally. It makes you wonder, what happens next? What will the next generation of clever, lossy compression techniques for AI models look like? Could we reach a point where we can not just run, but maybe even train surprisingly large models entirely on consumer-grade hardware? That's something interesting to consider as you start your journey.